Hello students, welcome back. Now let's go to section 2, exponential and logarithmic equations. This is going to be an extremely important section, especially in terms of exam preparation. Please expect at least 2, possibly 3 problems in the exam. 2 or even 3 problems in a single section of a single lesson. Oh boy, we are talking about something really heavy. Indeed, this has really heavy weight. Category 1, natural exponential equation. We have e to the some power and we have to identify that power. Category 2, we have natural logarithmic equations. Bunch of natural logarithms to identify and then look at the inside. Finally, exponential and logarithmic equations of arbitrary base. Okay, let's start with the first category, exponential equations. Problems A and B are similar types of problems. Please note that they are both quadratic equations. Do you see it? If you don't, well, stop the playback and try on your own. If you do, okay, let's go together. So, this equation here is actually a quadratic equation because e to the 2x power here is, as a matter of fact, exponential x squared. So what do we have? We have a quadratic equation to go. Now, how do we factor this? Good question. We have non-monic polynomials, so please stop the playback and try on your own. You can set up tic-tac-toe or whatever if you want to. Let's see. Shall I do that here? Insert table. Okay, all right. So first number times last number. 4 times 3 is 12. And factors of 12 must add up to -8. What do we have? 6 times 2? Yeah, 6 times 2 is 12. They add up to 8. We want -8, so you want negative. That's going to do it. Now let's fill this up. Everything should be multiplication, and the first column is all positive. So we're going to get 2 times -3 here. 2 times -1 here. Does it look good? Horizontally, vertically, all multiplications. Okay, all right. And then we go crisscross. Cross multiplication. Cross. So we have 2 -1 and 2 -3. Feel okay, everyone? Okay, we have the factorization, and of course right hand side is 0. That's why the factorization works. A times b is equal to 0. Therefore, one of them has to be 0. Maybe both, but in this case never both. So one of them has to be equal to 0, which means 2e to the x power minus 1 is equal to 0. Or 2e to the x power minus 3 is equal to 0. There's no way I'm going to get 0 by multiplying two non-zero numbers. Okay, so from the first, what do we get? Flipping 1 to the other side, this is equal to 1, and this is equal to 3. And furthermore, divide away by 2, so e to the x is 1/2. E to the x is 3/2. Okay, we successfully identified the exponential x. We want to find out x. So how do we get it from here? To remove exponential, we take the inverse function. We take the natural logarithm. So we take the natural logarithm of both sides. So logarithm of this, log of that, log of this, log of that, and then exponential and logarithm, they cancel each other out. So x is log of 1/2, or x is log of 3/2, and there goes the solution. Want to check out? Solve for e to the 2x power minus 8 e to the x power plus 3 equal to 0, and solve with respect to character x. Okay, forget about all this complex part. The reason is because Mathematica is based upon complex numbers. Log of 3/2, that's okay. And then forget about this. We have minus log of 2, which is actually equal to log of 1/2. So yes, that's correct. In case you're wondering, log of 1/2 is log of 2 to the negative first power. So it's negative of. So these two are the same. By the way, Mathematica uses LOG as natural logarithm. Again, the reason is because Mathematica is based upon complex number system. We, on the other hand, are doing a little bit of cheating because this is introductory level, so we are doing everything in real number system, and that's why we are using ln. If you go over to higher level mathematics, like 3000 or higher, then we never use ln, always we use log. Anyway, there you go. We have full solution there. By the way, we have answer key here, and there you go. Solve for e to the x, and then take the natural logarithm to find out. Oh, I calculated those with handheld calculator, or maybe Mathematica, I don't care which one you use. You get digit string as well. Not really necessary, but it's a nice addition. Okay, stop the playback and try the same thing to the second problem here. Can you do the same? Similar quadratic equation. I guess you should be able to do this. Go ahead. All right, did everybody try? Okay, I'll assume everybody tried. So let me go ahead a little bit more quickly. Okay, here we go. So we have quadratic equation like this. All right, factor like that. Okay, all right. And then first factor is equal to 0, so we have e to the x is 1/2. Second factor equal to 0, so we get e to the x is -3. Here, experienced students will be able to see that this doesn't work right away. Exponential is never negative. It's always positive. So this one is extraneous. You can see it right away. But let's assume you didn't see it. Let's assume you didn't see it. In that case, let's just go ahead. Okay, here I saw it. All right, okay. Let's just assume you didn't see it. So e to the x is -3. In that case, x is log of -3 because log and exponential cancel each other out. And punch in the calculator. What do you get? Log of -3. You tell me. Did you punch it in? What do you get? You're going to get an error message. What does it mean? Is something wrong? Yes, it means something is wrong, and that something is, that's impossible. Exponential cannot be negative. So error message in this case is actually very, very good. It helps you, you just stumble upon an extraneous solution. But I'm afraid those kind of cases are rare. Most of the time, when you solve an equation, you have to plug those answers back into the original equation and calculate out. Okay, do we have some more time for the next problem here? I guess I'll be more time for this one. And then we'll do these two problems in separate videos. Okay, this one first. Okay, we have denominator here this time. So let's follow the standard process. Step 1, denominator. Step 2, parentheses. Step 3, like term. Here we just go ahead with like terms and factorizations, but here we need those extra steps. Okay, let's go ahead, copy and paste this thing. So 5 is equal to 2e to the x power minus 1, which was there before. And then you have to multiply out the denominator, 1 plus e to the x power. Does everybody agree? Multiply the denominator to both left hand side and right hand side. In the left, we lose the denominator. In this right, we just multiply that. All right, let's go to step 2, parentheses. Break out the parentheses. So, all right. 5 is equal to, and then let's void it out. 2e to the x power plus 2e to the 2x power, because I multiplied this times that. And then inside, minus 1, and minus 1. And then finally, last, minus e to the x power. Did I get everything right? Please check. Just voiding out. And then let's move everything to the right hand side and then get a quadratic equation of e to the x power. 2e to the 2x power, that's quadratic. And then plus e to the x power, because we have 2 minus 1 here. And then minus 6 is equal to 0 after flipping this 5 to the other side. Does everybody agree here? Can this be factored? I guess so. 2e to the x power minus 3e to the x power plus. I think this is a correct factorization, isn't it? Let's see. Negative 3 times positive 2 is negative 6. That's all right. And then 2 times 2, that's plus 4. Negative 3 times 1, that's negative 3. 4 minus 3 is positive 1. Yes, I have positive 1 here. Okay, that's correct. And if you're unsure, you can always go back and set up tic-tac-toe or do whatever you need to do to factor a quadratic trinomial. And then setting up the first factor equal to 0, 2e to the x power minus 3 is equal to 0, or e to the x power plus 2 is equal to 0. From the first factor, we get e to the x power is 3/2, or e to the x power is negative 2. And do you see an extraneous solution right away? Exponential can never be negative, so this one is just coming out directly. As a matter of fact, even from here, experienced students will see. Oh, that never becomes 0. That's always positive plus positive, so just cross it out and then just go to this one directly. I took 2 extra steps to remove all those, but even if I forget after these 2 extra steps, get x's natural log of negative 2 and then punch in the calculator, you'll get error message. So even if you miss all these, still you're going to be doing okay. In any case, that's the right case. So by taking the logarithm of both, I'm going to get the solution. X is natural log of 3/2. By the way, if you use some symbolic computation tool, you may end up with this kind of solution. And of course, experienced students will see these two are the same. We have division, 3 over 2, 3 divided by 2. So logarithm becomes subtraction, log 3 minus log 2. But I don't think that kind of thing is necessary here. So let me just remove those and then let's just stop here.